Hi everyone, myself Hima. I'm a student of Sri Venkateshwara College of Engineering. Today I'm going to explain you about numerical aperture and its derivation. The theory of this states that the numerical aperture of an optical fiber is defined as light gathering ability of a fiber. Numerical aperture also refers to the maximum angle at which the light incident on fiber end is totally internal reflected and is propagated transmitted along the fiber. What is numerical aperture? Numerical aperture states that the light gathering capacity of an optical fiber is known as numerical aperture and it is proportional to acceptance angle. This is the numerically equal to sine E of maximum acceptance angle. The ratio between the difference in Ri of core and cladding of that of Ri of core is called the fractional change. What is a numerical aperture of an optical fiber? The definition states that the measure of an optical fiber ability to collect the occurrence light ray in it is known as numerical aperture. The short form of that is numerical aperture that eludes the efficiency with the light which is collected within the fiber to get propagated. We know that the light is propagated through an optical fiber during total internal reflection. So much multiple optical total internal reflection takes place within the fiber to transmit from one end to another. The small diagram shown below here, the acceptance angle consists a light ray of Xa that incident inside the optical fiber. The refractive index of core is N1 and the cladding is N2. So the ray Xa is launched from denser medium to layer medium, making an angle alpha with fiber axis. This angle alpha is known as acceptance angle of fiber. This incident ray propagates inside the fiber and get reflected completely by core cladding interface. Here the M1 medium N1 is the air medium and the N2 is the cladding. But for this angle of incidence should be more as compared to critical angle. Otherwise, if the medium angle is less than that critical angle, then rather there being reflected the ray get refraction. So the equation given below here, by the Snell's law, incident and reflected ray propagation is same plane. So application of the Snell's law at medium 1 as given in the figure as air and core interface, then n sine alpha is equals to n1 sine theta as equation 1 we going to consider. From the above figure we can read that theta is equals to pi by 2 minus theta c as the equation 2. On putting value of theta from the above equation in equation 1, we are going to get that n sine alpha is equals to n1 sine of pi by 2 minus theta c. N sin alpha is equals to n1 cos theta c. Sin alpha is equals to n1 by n cos theta c. This is by the trigonometrical identity we are going to make that equation 3. Since we know that cos theta c is equals to square root of 1 minus sin square theta c as equation 4. Application of Snell's law at core cladding interface, we get n1 sin theta c is equals to n2 sin 90 degree as equation 2 or equation 5, sorry. N1 sin theta c is equals to n2 and the n1 and n1 are going to come down at sin theta is equals to n2 by n1 as equation 2. 6. Substituting the above equation value in the equation C, we are going to get cos theta C is equals to square root of 1 minus n2 by n1 whole square. Substituting the above value in equation 3, we are going to obtain sin alpha is equals to n1 by n square root of n1 minus n2 minus n1 whole square. Sin alpha is equals to square root of n1 whole square minus n2 square by n as equation 7. As we have already mentioned in the medium 1 is air, though reflective index is n, we will obtain 1. So more specifically, we can say sin alpha is equals to square root of n1 square minus n2 square. Na is equals to square root of n1 2 minus n2 2. This is the expression for numerical aperture of an optical fiber having n1 as refractive index of the core and n2 as refractive index of cladding. So we can conclude that as numerical aperture shows that the light collecting ability of fiber, thus its value must be higher. As higher the value of a numerical aperture, better will be the optical fiber. This expression for numerical aperture of an optical fiber having n1 and the refractive index of core n2 as refractive index of the cladding. So we can conclude that numerical apertures as I mentioned before. The numerical aperture is applied in many uses. The application of numerical aperture includes the following: fiber optics, lens microscope object, photographic objects. Thank you for watching.